Alright, the formula for force is F equals ma, where m is mass and a is acceleration. If mass is measured in kilograms, then acceleration is measured in kilograms over second squared. What is the unit of force? When you read this, it seems like it would be complicated, but it's really super easy. All they're asking you to do is replace the variable m, which represents mass, with the unit it's measured in, which is kilograms. Okay, now m and a are being what? What operation is between them? Multiplication. So I'm going to put a multiplication symbol. A represents acceleration, and that's measured in kilograms over second squared. Okay, then you could take it a step further. Since you have kilograms times kilograms, couldn't you just write kilograms squared? And then over second squared. And that's all. Yes? Well, more than likely with something like this, it will just be multiple choices, and you pick the right one. Distance is described as d equals rt, where r is rate and t is time. R is measured in meters and t is measured in seconds, so what is the unit measure for distance? So d equals r, which is rate, and what is it measured in? Meters. And then they're touching, which means they're being multiplied. T, what is time measured in? Seconds. Okay? Alright, any questions off the first page? Alright, now let's move on to the next page. You can drive 1,000 yards in 1 minute. Convert this rate to yards per second. Okay, so they've given us the information in yards per minute. They want the answer in yards per second. So the only thing we've got to convert is what? Minutes to seconds, right? The yards is already in yards, so we're done with that. We don't need to do anything with that 1,000 yards. We need to take this minutes and to do it to seconds. If minutes is down here, what has to go up here? Minutes. And what do you know about minutes converting to seconds? Right. Okay, so now look. See how you have a minutes on the bottom and a minutes on top? That means they cancel each other out. And that leaves yards that didn't get canceled and seconds didn't get canceled, which is good because that's what we want our answer in. Now you just multiply across. 1,000 times 1 is 1,000. And then 1 times 60 is 60. And then you divide those and you get 16.67 yards per second. Okay, number 9. Number 9, you have an apple tree in your backyard. You collect 1.6 pecks of apples each day. How many liters do you collect in 1 week? Okay, so you'll see that they've given us the information in pecks per day. But they want the information in what? Liters per week. So not only do we have to change over days to weeks, we also have to change from pecks to liters. Well, they give you the information you need for that in the parentheses. And they started off for you. They started off because they know that you collect 1.6 every day. 1.6 pecks every day. If pecks is up here, pecks has to go down there next. And they told you 4 pecks equals 32 quarts. So that's why they wrote that. But we're not trying to get to quarts. We're trying to get to liters. So now if we put quarts down here, because quarts was up there, do you know anything about quarts to liters? Right, look. Right, they told you in the question that 1.06 quarts equals 1 liter. Okay, so now we filled it all in. See how the pecks is on top and bottom so it cancels? Quarts is on top and bottom so it cancels. But liters is on top and nowhere on bottom so it doesn't cancel. Which is good because we want our answer in liters. We don't want it to cancel. And then also you'll see that days is top and bottom so it cancels. But week is not. So that's good. We wanted it. We didn't want it to cancel. Now you multiply straight across. So go ahead and multiply all 4 of those numbers. 1.6 times 32 times 1. Okay, what'd you get? 358.4. Now for the numerator, the denominator, you multiply those numbers. 1 times 4 times 1.06 times 1, and what do you get? Right? And then you have to divide those. 80 what? 84.5. What came after the 2? So shouldn't that round up to a 3? And that's 84.53 what, Samantha? Well, you need to pay attention. Liters per week. Okay, number 10. With number 10 and 11, you got to do all the work yourself. They're not giving you most of it and letting you just fill in the missing parts. You got to do it all yourself. So really pay attention to these. You decide to drain your pool for the winter. The water drains out at a rate of 50 gallons per day. How many pints per second is the water draining? Okay, they gave you the question in what units? Gallons per day. They want the answer in what? Pints per second. Doesn't that mean we have to change gallons to pints and days to seconds? Okay, well let's just start with one at a time. Let's start with 50 gallons. And we're going to change it over to pints. Okay, well everybody should know by now that if we start with gallons up here, we have to have gallons down here. If you look at your little conversion chart we made, what do we know about gallons? 1 gallon equals 4 quarts. You better have that with you on Monday or you're not going to be able to use it. Okay, but we can't stop there because we're not trying to get to quarts. We're trying to get to pints. So now quarts has to go on the bottom. And what do you know about quarts? Right. Okay, so now look, I've made it to pints, which is good because that's what I was trying to make it to. And everything else crosses out. But we're not finished with the problem because if we stopped here, that would be pints per day. We've got to now convert days to seconds. Okay, so I'm going to go back over here under 50 gallons and write 1 day under it because weren't they doing 50 gallons in 1 day? So that means over here, what will have to go in the numerator? Days. That way they'll cancel out because one's top, one's bottom. Okay, tell me what you know. Right, 1 day is 24 hours. Then what has to go up here next? 1 hour is, okay, but we can't stop because we're trying to get to seconds. So 1 minute is 60 seconds. Okay, so now look, everything crosses out nicely. Days and days cancel out, hours, hours, minutes, minutes, leaving just seconds that don't get crossed out, and pints, which is good because isn't what they want what they want the answer in? So now all you have to do is multiply the numerators, multiply the denominators, divide them, and you have your answer. What do the numerators multiply to be? What do the denominators multiply to be? 86,400? Okay, and then you're going to divide those and you get 0.005 pints per second. Does that make sense? Okay, number 11. A train travels 80 miles in 2 hours. What is the train speed in feet per second? Okay, so what did they give us? What units?
Miles and hours.
Right, and they want the answer in feet per second. So first, let's just worry about the 80 miles. Let's convert that over to feet. 1 mile equals what?
280.
Right, and then aren't I done with that part of the chain because I've now made it to feet? Okay, because look, that cancels out and that cancels out, leaving feet, which is what we wanted. But we're not finished because we also have to put that 80 miles was done in 2 hours, and now we want those hours in seconds. So what do I do next? 1 hour, 60 minutes, and 1 minute is 60 seconds, right? And now you'll see that the hours and hours cancel, minutes and minutes cancel, and you're left with feet and seconds that was not canceled, which is good because that's what they want the answer in. Now you multiply the numerators. What do you get when you multiply 80 times 5280 times 1 times 1? 422,400. And then what do you get when you multiply those denominators? 2 times 1 times 60 times 60. Right, 7,200. And then what do you get when you divide those? So like 6, 7, and that's feet per second. All right, number 12. Everybody got it? What unit rate would be used to describe the temperature change? Okay, you always look at the y-axis first. What unit is on the y-axis? Dollars. And then per degree. Okay, because temperature is not a unit. The unit we measure temperature in is degrees. I'm not sure. I have to look at it. I'm not sure. Okay, next page. Now we're moving on to simplifying radicals. The first thing that I want you to do when you're simplifying these radicals is I want you to type it in the calculator. Okay, so the square root of 18. Is that a perfect square?
No.
No. How do you know? Right, well, no, y'all are thinking rational, irrational. It's not a whole number. Okay, perfect squares are when you take the square root of a number and it produces a whole number. Since it's not a perfect square, that means we're going to have to simplify it using a factor tree. So what numbers will multiply to give you 18?
9 times
6 and 3.
Right, 6 and 3, 9 and 2. You can start either way. No matter how you start, aren't you going to end up with a 3, a 2, and a 3 at the bottom? Now, even though those are not side by side, there's still a set of 3s there, right? A pair of 3s. So just circle them like this. So the only thing that wasn't circled was the 2. And where does he go? Inside. Out of the ones who are circled, get rid of 1, kick 1 out, and there's your answer. Now remember, we already typed in the square root of 18. Now type in your answer, and you will confirm that you did it right. See how you get the exact same thing? That lets us know we got it right. So there's no reason you should miss these on the test when you can type them in like that. Yes, JJ? You mean like if there were an extra number that didn't get circled? It would have multiplied by the 2 on the inside. All right, number 14. The first thing I want you to do is type in the square root of 250. Is it a perfect square? Shh. Is it a perfect square? No. So we're going to have to factor tree it. What numbers multiply to give you a 250? Okay, that's a good start. Then 10 breaks down into a
5 and 2.
and 25 is 5 times 5. And then those all 4 are primes. So you're done. You're ready to circle. Get rid of one of those 5s, kick 1 out. And then look, this time we had 2 people that were being good. So when they go back inside, what do they make? A 10. Now always check it. If I type in 5 square roots of 10, I will confirm that I did it right, because it gave me the exact same answer that I got when I typed in the question. Shh, y'all need to focus. 3 square roots of 68. 3 square roots of 68. What's different about this one? Right, that's just a kid that got kicked out earlier this year, okay? So just ignore him for right now. We're going to factor tree 68. What are the factors of 68? Okay. And what are the factors of 34? Okay, so don't we end up with a 17 and then 2 2s? Can 17 be factored more? No, why not? It's prime. Okay, so we circle the 2's, kill one, kick the other one out, and then 17 goes back inside. So is that your answer? No, so let me show y'all something. Type in the question of 3 square roots of 68. And you get that. Now if I were to type in 2 square roots of 17, because I feel like I've done everything right so far, why is it not the same?
Because you didn't multiply it to the outside.
Right, this 3 that was already there now joins with the 2 to make 6 on the outside. They multiply together. So now when you type in 6 square roots of 17, it does match the question. Okay, number 16, square root of 81.
9.
9. Why is it that when you have a perfect square, there's no more radical? Okay, think about it with your little scenario. If you factor tree it, 9 times 9. So look, everybody either gets killed or kicked out. And so if there's no good kids, nobody goes back inside, there's no need for the house. Okay? Alright, number 17. They want you to add those radicals. To be able to add or subtract radicals, what's the rule?
The basic should be the same. Or the biggest.
Right. Does anybody remember the name of that thing on the inside?
No.
Radicand. Okay, but right now they have different radicands. One's 12, one's 27. The same radicand. So right now they don't. So that means we can't add them. However, if you take them over here to this side and you simplify both of them with a factor tree, maybe then they'll have matching radicands. So let's try it. What are the factors of 12?
3 and 4.
Okay, either would work. 6 then breaks down into a 3 and 2, and then 2 drops down. So don't we have a pair of 2's? Right. Okay. What else do I need to do though to this one?
Also multiply by
That
3.
3 joins the 2 that got kicked out, making a 6 on the outside. So 3 square roots of 12 is equal to 6 square roots of 3. Now let's hope that when we simplify this one, we get a square root of 3 so that we can add them. So let's see. What are the factors of 27? 9 and 3. Okay. Circle, kill, kick out, put back in. Now look, they're both square roots of 3. So when you add them, it's going to still be square root of 3. You don't actually add those inside numbers. They just have to match. To be able to add, you only add the outside. So you get a 9. Well, we just made them match. You just couldn't combine them. You would just leave them apart. Yeah. All right, number 18. This time they want you to subtract, but currently they cannot be subtracted because this one has a radicand of 54, this one has a radicand of 24. But maybe if we go over here and we simplify each of those, maybe then they will match. So Chloe, what numbers multiply to give 54? Well, it's an even number, so divide it by 2. You could. Okay, 9 and 6. What multiplies to get 9? And then what multiplies to get 6? Okay, so what do I circle? All of them? Okay. And then what goes inside? Which make? 6. You multiply them. Okay, so the square root of 54 just became 3 square roots of 6. Now let's simplify the square root of 24. Sure, JJ. Okay. 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 Right? Okay, now look. Now they both are square root of 6. So all you need to do is subtract. The outside numbers, 3 minus 2 is 1, and you don't even have to write the 1. It's understood. No. When adding and subtracting, you don't actually do anything with the inside number. You just have to make a match before you can do anything with the outside numbers. Okay, number 19. Focus. We're getting near the end. Which number is equivalent to 6 square roots of 12 times 7 square roots of 18? This is just a fancy way of asking you to do what? But by what method? Multiplication. All they're saying is multiply this and then tell me what it's equal to. So, JJ, when you multiply radicals, do the radicands have to match? No. That's only when you're adding and subtracting. When you're multiplying radicals, you just multiply the outside numbers. So in that case, that would make a what on the outside? What's 6 times 7? 42. And then you multiply the inside numbers. What's 12 times 18? Right? Now, when you look at your answer choices, you won't see that because it can be simplified. So what can I do? Okay, so give me some numbers that multiply to get to 216. 4 and what? 4 and what? 54? Yeah, or 1082. Okay, we'll start with 4 and 54. Okay, 4 then breaks down into 54, 6. Okay. So what goes outside? And what goes inside? Am I done? Right. Remember this 42 that was already on the outside? It now comes down, multiplies by 6 to make 252 square roots of 6. Now I want everybody on your calculator to type this in and type this in and make sure they match. Where's my last page? I know. How can you determine if a number is irrational? Right. If the number does not repeat or terminate or become a fraction, it's irrational. Number 24. Find the perimeter of the rectangle shown. Well, you kind of have to know how to find the perimeter of a rectangle. How do you do that, Chloe? Well, then that's why you should be paying attention. I know, but how do you find the perimeter of a rectangle? Y'all got it? Nobody has told me how to find the perimeter of a rectangle. Okay, Jenny Beth. Add all the sides. Okay, well I can add this side and this side, but they didn't give me this side and this side. Right, it's a rectangle, so that means this one's also the square root of 20, and this one's also the square root of 45. So, Jenny Beth said perimeter of a rectangle, you add up all the sides. So if I add square root of 20 plus square root of 20 plus square root of 45 plus square root of 45. Do they all have the same radicand? No. But don't these two have the same radicand? Yeah. And isn't there an understood 1 outside of each of them? So how many square root of 20s do we have? 2. And how many square root of 45s? 2. Can you combine those? No. However, both of these can be factor tree. What are the factors of 20? Okay, so look, circle, and don't forget this 2, we'll make that become a 4. Okay, so the square root of 20 plus square root of 20 became this. Now we have to do 45. What are the factors of 45? Okay, that becomes 3. Okay, don't forget this 2 makes it a... Now do they have the same radicand? So now roots of 5.
I basically just skipped on the add and went straight into the
Okay, simplify the square root of 5 minus 3 square roots of 5. Well, can you subtract them? Yeah, they're both square root of 5s. So what do you actually subtract though?
1 minus 3.
1 minus 3, which is negative 2.
I didn't put the negative.